Hi everyone, my name is Dennis DeBow and I've been at Databricks for almost 2 years now. In my role, I manage a team of partner solution architects entirely focused on the AWS platform. Now let me give you a quick overview of Databricks. We are a SaaS company and we offer a unified data analytics platform that really allows three core personas to come together and collaborate with data to drive business outcomes. The key personas are the data engineer, the data scientist, and the data analyst. Now, most people know that our co-founders are the original creators of the open source Apache Spark project. And we are. Our company was founded in 2013, and Spark has become the most popular and adopted open source project in the industry for large-scale data processing and data science workloads. We at Databricks are inspired by a data-native driven vision and recognize that it takes more than a great processing engine to build a modern data analytics platform in the cloud. In addition to Spark, we've continued to innovate and contribute to a variety of open source projects, and one of them is Delta Lake. Ultimately, you'll want to build a modern open data lake and address all your analytics use cases, while enabling your data teams to be productive and help them harness all your data easily and with reliability. We will cover Delta Lake in depth today. We also launched MLflow about 1.5 years ago. MLflow is still the only open source machine learning governance and lifecycle management platform out there today. It has more than 2 million monthly downloads and 100 plus contributing organizations. MLflow can help anywhere from how do I track my experiments that I'm running, up to machine learning experiences, all the way to how do I build a promotion path for my ML models, and ultimately, what are those approval gates that I have to go through before promoting a new model into production. Think of CI/CD for ML or MLOps principles. Lastly, we recently acquired Redash, an open source company that provides an easy to use dashboarding and visualization solution focused on SQL analytics. It has more than 7,000 deployments globally, and we are excited to welcome data analysts in our broad and growing open source ecosystem. Redash makes it very easy for our customers to generate insights using SQL on your data lake. We are very aware that many organizations are struggling to provide a data platform that makes data ready for analytics. I mean, every organization has the desire to get more value added out of their data assets. And most unfortunately, are realizing that their existing architectures and approaches are failing. First, we have to look how these data systems have evolved over the last few decades to really understand why so many organizations are still struggling with analytics. Data warehouses came around in the 1980s and were purposely built for BI and reporting. They were, and they are still, great at answering quantitative and performance metric predefined questions. Typically, a schema is well defined before the data is ingested, and applying change is often difficult, lengthy, and cumbersome. Over time, they have become essential, and today, most enterprises have one or even many of them. However, they're not built for modern data use cases. They have no or limited support for data like video, audio, text, and real-time streaming. Datasets that are crucial for modern use cases. As a result, there is no viable support for data science or ML and AI. And moreover, they are closed and proprietary systems. They force you to lock your data in so that you cannot easily move that data around. And so today, most organizations have adopted a pattern of first storing their data in their data lake using cost-effective storage, and then move dataset or curated datasets into their data warehouses. So then the thinking was that hey, maybe data lake could be the answer to all these problems. Data lakes, on the other hand, emerged about 10 years ago. And they were great because they could indeed handle all your raw data in a very flexible manner. Most of you have probably heard of it. Schema on read concept. And therefore, they're very good for data science and machine learning use cases. And regardless of the use case, data lakes serve as a great starting point for most enterprises today. Unfortunately, they are not very good at supporting the data warehousing and BI use cases. Most that have managed or configured a data lake will agree that they are very complex to set up. Then, maintaining processing performance is very challenging and requires sophisticated engineering skills to constantly optimize the workload and ensure reliability of the data pipelines. And as a result of that, many data lakes have turned into unreliable data sources. The data lake has all the data, but it's very difficult to make any sense of it. And hence the industry term, data swamps. So understandably, in the absence of a better alternative, we see a strategy of coexistence in the enterprise. Then as a result, most organizations are ending up with multiple data silos and separate technology stacks to support for their data science, machine learning, and business analytics use cases. This coexistence leads to increased costs, complexity, duplication, and silos of data, not to mention a nightmare for IT departments. So what we've begun to see in the last several months is the emergence of a new paradigm in our industry, the lakehouse. This data management paradigm truly brings together the best element of the data warehouse as well as the best features of the data lake. In the lakehouse architecture, you can have all your data in one centralized location using an open file format. Structured data, semi-structured data, and unstructured data, enabling all your use cases from reporting, analytics, to cutting-edge ML and AI use cases. The lakehouse is distinct from a data lake. The lakehouse is enabled by a new system design by implementing similar data structures and data management features to those in a data warehouse, directly on the most cost-effective, highly reliable, and durable object storage used for data lakes. One platform, one centralized data lake for all your use cases in a modernized platform. So it is essential and critical to have a transaction layer as part of the modern data lake architecture by bringing structure and reliability to your data lake with the following key features. Transaction support. Support for ACID transaction to ensure consistency as multiple parties concurrently read or write data. Schema enforcement and governance. The lakehouse should have a way to support schema enforcement and evolution, similar to a data warehouse schema paradigm. BI support. A lakehouse should enable using BI tools directly on the source data. This reduces staleness, latency, and lowers the cost of having to operationalize multiple copies of the data in both a data lake and a warehouse. Storage is decoupled from compute. In practice, this means storage and compute use separate clusters, therefore enabling and scaling concurrent users in larger data sizes and audiences. Some modern data warehouses also have this property. Openness. The storage format that they use are open and standardized, such as Parquet, and they provide an API so a variety of tools and engines, including ML, Python, and R libraries can efficiently access the data directly. Support for data types ranging from unstructured to structured data. The lakehouse can and should be used to store, refine, analyze, and access data types needed for many data applications, including image, videos, audios, text, and etc. And it should also support an end-to-end streaming capability. So now, let me introduce you to the Delta Lake open source project because it is uniquely suited to address every of these challenges and requirements we've just outlined. From the ground up, Delta Lake has been designed to bring the best elements of the data warehouse and the indispensable features of the data lake together in an open manner while enforcing reliability, quality, and providing the expected performance characteristics to satisfy all your use cases. By the way, in October 2019, the Delta Lake project joined the Linux Foundation, which was a big milestone for the Delta Lake project. So here are 9 challenges that you will typically encounter in the data lake. And let's take a deeper dive into Delta Lake and see how it solves all these challenges that we've been talking about with respect to the data lake. The first 5 challenges that you'll run into with traditional data lakes are addressed by the Delta Lake ACID transaction support. Delta Lake ensures that either a transaction fully succeeds or when it fails, that the data is rolled back and never left in a corrupted state. ACID transaction support also enables you to simplify your data pipeline and mix real-time streaming and batch operations concurrently. Delta Lake does this by keeping a transaction log of every operations and enforcing the readers and the writers in the right sequence. This is great for GDPR and CCPA and as well as other industry regulations. With the Delta log, transaction log, Delta enables to go back in time and look at any versions of data, providing a time travel capability. So now how does Delta Lake handle large metadata? Well, it uses Spark under the hood for managing metadata, which enables us to scale infinitely. A portion of it is cache and optimized for faster access, some of our secret sauce, and then the data and its metadata always coexist. So we can scale the metadata at really large petabyte scale. Performance is always top of mind, and to help, Delta Lake has indexes because partitioning alone is not sufficient for performance. We also have features like Bloom filters and data skipping, which are various statistical techniques that let us, when we get a query, to look at the data and actually avoid reading a large portion of the data altogether, and therefore get faster time query and for various types of queries. Z-order, which lets us lay out the data in a way in which you can actually have multiple columns that are all optimized. And then finally, we have an auto-optimized feature which periodically reorganizes the data in the background so it optimizes it for later usage. For instance, if you have a lot of tiny files, auto-optimize will compact them into optimal file sizes on your behalf. And finally, how do you handle the data quality issues? Well, Delta comes with schema validation and evolution features. This means that every data type goes into a Delta table must strictly comply to the schema definition. We will make sure that it always satisfies that schema. And if it doesn't, we move that data into a quarantine where you can actually go look at it later and fix it. And you can also evolve that schema over time. But from a performance perspective, indexing, Bloom filters alone is not enough for all the lakehouse workloads. You'll need a lot more. What you'll need is a fast execution engine for all your analytics workload. And you'll need a high-performance query engine that can deliver the performance SLAs criteria for all your analytics workload. Databricks recently introduced the Delta Engine. Delta Engine is a high-performance query engine built from scratch for Delta Lake and, of course, Apache Spark. It includes an improved query optimizer and a vectorized execution engine to speed up your data workloads. So, in summary, the Delta Lake, as a structured transaction layer on top of your data lake, allows you to overcome a lot of the challenges that historically has cursed the data lake: asset transaction, indexing, fine-grained control, and schema validation, evolution, and expectations. Then, to ensure that all analytics workloads can be executed very fast at scale, a low latency query engine is a huge multiplier for Delta Lake implementation. And we think Delta Engine, with its vectorized query engine, query optimizations, and custom connectors, combined with enhancements that substantially improve price performance for analytics workloads, make Databricks the ideal platform to deploy Delta Lakes. Finally, all of this comes together in the way that data is actually made useful. Redash is going to simplify dashboarding for many analytics and analysts and data scientists. The data workloads and the data platform working together end to end is the heart of Databricks' unified data analytics platform and our vision for data teams. Let's switch gear a bit and discuss the Redash announcement we made earlier this year. Redash has joined the Databricks family, and we plan on bringing this product to all of our Databricks customers. So let's get into what Redash is all about. The heart of Redash is really a query editor, a rich experience for those of you who love SQL with autocomplete, formatting, snippets, and more. Once you get the result you need, you can visualize them easily. Every query can be visualized with a wide variety of visualizations and then group into a dashboard to tell your story. These dashboards can be shared with your team and organization and quite easily, actually. All right, so now that we know all about Delta Lake, the lakehouse, and the Redash announcement, I just wanted to take a few moments here and really outline how Databricks on AWS fits into the AWS landscape. So if you take this diagram from left to right on the 4 pillars of data ingestions, data engineering curation, serving, the serving layer, and the analytics layer, there's a numbers of first-party service that Databricks integrates with, like Kinesis, S3 obviously, Glue, and also all of the other serving layers like SageMaker or for that matter, Redshift. And a nice integration with Athena as well. So those are the prime data and AI first-party services. Now, one thing, we mentioned earlier that Databricks is a SaaS product, and Databricks does deploy all of our clusters, and the EC2 provisioning is done within the customer's VPC. So if there's a few takeaways here to take, is not only that we integrate with first-party services from a data and AI standpoint, but all the provisioning and all of the ecosystem within the customer's VPC. So those instances, all the strong compute and separation of storage, leveraging S3, is all done within the boundaries of the customer. We've also recently announced our availability on the AWS Quick Start program. So now you can actually deploy a Databricks workspace quite easily in about 10 to 15 minutes using the Quick Start. A very powerful feature and easy feature to follow to deploy Databricks on AWS. Now at the bottom, there's a numbers of additional that you call additional services that most enterprise would look for integration. For instance, Databricks as a secure provides a deployment in a very secure manner, and therefore we have a full integration with identity access management. We also support CloudTrails, AWS Config, SSO, and a numbers of other services as well that you would expect from an enterprise-grade software. So let me just tell you, about one of our customer, Digital Turbine, which relies on several streaming data sources to determine how best to serve their apps to their end users. Now they have about 180 million events that flows through their data system, including mobile events, events that are derived from the activity on their app, as well as some legacy mobile events that they've categorized a little bit differently, and as well as campaign and all the installation, application installation, and so, numbers of different events. All stream sources are brought together into a data sync where the unified mobile events are used for BI analytics. So legacy events were sent to Amazon Redshift, and campaigns events were stored in a data lake, then aggregated by Apache Spark and ultimately written to Redshift for revenue reporting. However, the Digital Turbine team was struggling to maintain an architecture that contained mostly self-managed clusters, and they wanted to standardize their ETL approach, and then were only able to run batch ETL for legacy events. So their setup resulted in a higher cost and the inability to deliver on a service level agreement that they had agreed with their stakeholders. Using Databricks Delta Lake on AWS, Digital Turbine built a scalable event streaming platform in just 1 month that accelerated their query responses and met their SLAs. So they produced awesome results. They were able to build this new streaming platform, like I said, in about a month. They created solutions that makes data available in minutes, delivering those 180 million events per day and achieving 5.9 SLAs. Great story, great success stories. Now, Comcast is another example of a media company that has successfully adopted data and machine learning to create new experiences for their viewers. That really helps improve satisfaction and customer retention. They've built a voice-activated remote control that allows you to speak into the remote and ask a question. If you're a Comcast customer, you're really familiar with this feature, and it'll provide some really relevant results, leveraging cool things like natural language processing and deep learning. There are some stories about some of the pronunciation and the results you might get, but all in all, it's been a great feature, and they've built it on top of the Databricks platform. So the challenge was instantly answering a customer's voice request for a particular program while turning billions of individual interactions into actionable insights, strain the Comcast ID infrastructure. And their data analytics and data science teams was really stretched. To make matters more complicated, Comcast needed to deploy models to a disjointed and disparate range of environments, cloud, on-prem, and even directly to devices in some instances. So massive data, billions of events generated by an entertainment system, and 20 plus million voice remote, resulting in petabytes of data that needed to be sessionized for analysis. Fragile pipelines, complicated data pipelines that frequently failed and were hard to recover. Small files were difficult to manage, slowing data ingestion and downstream machine learning. Another challenge was the poor collaboration. The globally dispersed data science and working in different scripting language struggled to share and reuse code. So managing of the ML models and the friction between dev and deployment. The dev team wanted to use latest tools and models while op wanted to deploy unproven infrastructure. So the solution that Comcast came up with was they realized they needed to modernize their entire approach to analytics and data ingestion in order to deploy machine learning models that could deliver new features to delight their customers. So today, Databricks Unified Data Analytics Platform enables Comcast to build rich data sets and optimizes machine learning at scale, streaming workflows across team, foster collaboration, reduces infrastructure complexity, and delivers superior customer experiences. So simplify infrastructure management, reduce their cost, automated cluster management, and the cost management features such as auto scaling and spot instances were centered to their solution. Reliability of small files using Delta Lake to manage and optimize the file, so rapidly and reliably ingesting at scale, as well as the interactive notebook collaboration, improve their cross-team collaboration and data science creativity, allowing Comcast to greatly accelerate the model prototyping and really faster ideation as well and iteration. The reliable ETL at scale was provided by Delta Lake. It provided efficient pipeline and scale that can reliably join historic and streaming data for richer insight in sizes of data sets that they weren't able to accomplish before. So the impact was an intensely competitive entertainment industry. There's no time to press the pause button. Armed with the unified approach to analytics, Comcast can now fast forward into the future of AI-powered entertainment. So keeping viewers engaged and delighted with competition, beating customer experiences. So this is a great story. Comcast has been a great Databricks AWS customer, and we continue to increase a high collaboration on a numbers of different fronts, and in terms of data and AI, as well as product integration on the AWS platform. Let's switch to the demo now. Okay, so I've now switched to my demo environment, and I'm logged into the Databricks welcome page. So for those of you that are not familiar with our environment, there's a couple of important links that I'd like to share with you. One of them is the product documentation. So all of our product documentation is readily available from this page, as well as the knowledge base and the help center as well. And there's some training and some forms as well that are available. So what I'd like to do as well next is to show you the latest release notes that are also available from that page. So now I'd like to bring your attention to this new icon here at the bottom left, which allows you to toggle between the newly dedicated SQL native analytics as well as the data science and engineering workspace. So far today, I've highlighted the importance of the data analyst persona in the enterprise, as well as the integration of Redash into the platform. And finally, the new and improved vectorized Delta query engine, which can deliver up to 9x a better price performance for SQL workloads. So let's dive into it. Again, the documentation is readily available from your fingertips, fully searchable, all the documentation about our SQL Analytics workspace, as well as how to actually connect other BI tools to the different endpoints. Okay, so I do have an endpoint already running. And from here, you can actually get all the connection details from the summary tab that are necessary to connect your JDBC, via your JDBC URL, any of the additional BI tool that are documented and supported. So now that you have an endpoint running, actually, let's go over and create a brand new endpoint. It's as simple as providing a name, defining the actual t-shirt size, and as well as either enabling your auto termination, which is a good practice to have, as well as defining if you want to scale the load balancing of the endpoints or the clusters that are supporting your query workload, depending on as your query increases and concurrency, then you might need more additional cluster to satisfy the query load. So you can turn this on if you're going to have a lot of concurrent usage, as well as defining or enabling the Photon, which is our Delta engine. You can turn this on, and defining whether you want to use cost optimized spot instances versus on-demand instances. And one more options is you can actually start adding permissions to it or tags to your resources. So I'm going to cancel out of this because I already have an endpoint running, which I'll be using. And I can actually go look at the list of queries that are available. I can create brand new queries as well. And I can look at the query history that I've ran versus as well as uh, queries from all the users, and I can specify a period of time as well. So let's go to the queries. I'm going to go to the first query that I've ran. So I have a couple of a chart. I have a scatter chart and a bar chart, and those were ran on different dates. And I can actually go in here and edit the source. I could you know, modify this query that I have here. I could actually add parameters to it. I can also format the query, and I can turn on live autocompletes as well. So it's as easy as running this or adding a new visualization with this data. I can quite easily do this. And let's say a pie chart. I'll do carriers, cancel flight. Here we go. So I'm going to save this. And I have a third visualization. So from these visualizations, now I can actually go create a dashboard if I wanted to. So let's go pick up another query. And this one's actually a count. So if you were to modify this, you can actually, another way to do this is to build your query directly from the list of tables, and as well identifying the list of basically columns, and you can start autocomplete these queries quite easily using a sophisticated UI that you would expect from any BI tools. So here it is. You have your query history, you have your endpoints, numbers of queries, and from the actual visualization, you can start now creating dashboards as well. So let's get back to the presentation. All right, so thanks for watching the demo. And for more information and free training, you can always go to databricks.com/AWS. There's a fair amount of content on some of the customer stories that we have, additional customers that have shared their stories with us, as well as the training, and that content is ever changing all the time. So please make sure to go and visit that site to get the latest news. So on that, that completes the session. I'd like to thank you. Make sure you fill out the survey at the end, please, to give your feedback on the session. And thank you very much.